Hi guys, in this tutorial, I'm going to solve question number 7, paper 33 May 2021, Cambridge. Question number 7, it's given a curve. For the curve shown in the diagram, the normal to the curve at the point B with coordinates X and Y. This point, X and Y. So the coordinates of M will be X and 0. Pn is normal. What is the gradient of the normal? The gradient of the normal, dy by dx, is gradient of tangent. Gradient of tangent. So the gradient of normal will be negative reciprocal. Negative 1 over dy by dx. This is the gradient of normal. Gradient of normal. So Pn is a normal passing through point X and Y, meet X at N. So the coordinates of the point N, let's say, write it K and 0. The point M is the foot, means perpendicular from P to the x-axis. So this is a right-angled triangle. The curve is such that for all values of x, where is x between 0 and half pi, the area of triangle PMN. Area of triangle MN, you can use area of this triangle is half base into height. Have base into height. Where is the base? The length of MN into the perpendicular height, which is Y. So the area of this triangle is base into height, if it is needed. Part A. And the area of triangle given also is equal to 10x. Part A, show that MN divided by Y is equal dy by dx. First, you have to read the question, which is given, start with it. It's given the normal to the curve. I will start from this point. What is the gradient of Pn? The gradient of Pn, as I wrote it here, is equal to negative 1 over dy by dx. And also you can find the gradient by using 2 points. So the gradient of the line Pn, the gradient of the line Pn, y2 minus y1 over x2 minus x1. If we start with this point, 0 minus y, y2 minus y1, divided by k minus x, y2 minus y1, y2 minus y1 over x2 minus x1. I use the points, let's say this is x1, y1, and this is x2 and y2. So after finding the gradient, we want to connect between y, length of mn, and the dy by dx. So if we equate the two gradients, which is negative 1 over dy by dx, is equal to minus y over k minus x. You can cancel negative with negative. What is the relation between k minus x and mn? Is it same? Yes, same. The length of this line is k, and the length of this line is x from the coordinate. So this part will be k minus x. So k minus x is mn. Remove it, cross multiplication. So dy by dx, if you remove this part and write mn, and cancel negative with negative, reciprocal for each, you will get dy by dx is equal to mn over y. I will write by the same arrangement which is written, mn over y is equal to dy by dx. This is part 1. Hence, show that x and y satisfied by differential equation have y squared. There is another information given about the area of triangle. I will get the area of triangle by using half base into height and the area of triangle which is given and equate. We'll try to get this equation. The area of the triangle is equal to half base into height. Half base into height is equal to 10x, which is given in the question. So half the base is mn. The base is mn. So you can find mn as a subject from this equation will be dy by dx. mn is equal y times dy by dx. And the height is y. The height of the coordinates is y. So write half base, which is y, times dy by dx, into height, which is y, is equal to tan x. Simplify, y into y will be y squared, have y squared dy by dx is equal to 10x. This is the differential equation, which he asked to show that in part 2. Now, sure, you have to solve this equation, given that y equals 1 and x is equal to 0, solve the differential equation, separate the variables, x with x and y with y. So have y squared dy is equal to tan x by dx. Then start to integrate both sides. Integrate of y squared, add 1 divided by the new power. So half divided by 3 will be 1 over 6y cubed, simplified, is equal to. How to integrate tan x? If you remember, integrate of tan x, we'll write it as sine x over sine x by dx. Is it a function and its derivative up? Yes, but we need a negative sign. Differentiation of cosine is negative sign. Now it's correct. So the answer negative ln denominator, ln cosine x, then plus c. I will write the general form for this integration. If we have a function, integrate a function f dash x over f of x by dx. So the answer directly will be ln of the function in denominator, and you have to write a modulus sign because maybe it's a negative, you have to change it to be positive. So now integrate of tan is negative ln cosine x, negative ln cosine x plus c. You can raise negative 1 up to be cosine all to the power of negative 1, which is sec x. Or you can keep it if it is not written in a specific form for the derivative. So I will write it negative ln cosine x plus c. How to calculate c? It's a given information about values of x and values of y. Remove y and write 1. So 1 over 6 multiplied by 1 cube is equal minus ln cosine x is 0 plus c. Cosine 0 is 1. ln 1 is 0. So 0 plus c is equal to 1 over 6. So c is equal 1 over 6. Now, the final answer, 1 over 6y cubed is equal to minus ln cosine x plus c, which is 1 over 6. Now, if it is written, solve the equation only, you can keep your answer in any form. But if it is written y in terms of x, you have to continue. It's written y in terms of x. Multiply all by 6. So y cubed is equal minus 6 ln cosine x plus 1. Then by taking a cubic root of negative 6 ln sine x plus 1. This is the final answer, y in terms of x. Thank you.